Hi young chaps, it's time to apply all our concepts which we have learnt in the chapter triangles over these 10 questions which are going to come up right now. Very, very important from your examination point of view as well. Let's look at the first question. The questions are going to be according to 1 mark, 2 mark, 3 mark and 4 mark. So let's look at the first question for 1 mark. In two congruent triangles ABC and DEF, if AB is equal to DE, BC is equal to EF, name the pairs of equal angles. You are just given that ABC and DEF are two congruent triangles. This is not that pattern of representation of the two triangles which is going to give you the correspondence between sides and angles. You have to find that out on the basis of these equalities. What is given to you? It's given that the side AB of the first triangle is equal to side DE of the next triangle. The side BC of the first triangle is equal to side EF of the second triangle. So I can write in triangles ABC and DEF, we have AB is equal to DE, BC is equal to EF. We have learned how to develop correspondence between vertices from the equalities which are given corresponding to the sides or angles of one triangle and sides or angles of the other triangle. So here AB is equal to DE, there are 3 vertices A, B, C over here and there are 3 vertices D, E, F over here. You can see A is corresponding to D, B is corresponding to E and C is corresponding to F, right? This is the required correspondence between vertices of the two triangles. This is the correspondence between the vertices of the two triangles based upon which they are coming out to be congruent. Okay? This is the required correspondence between the vertices of the two triangles such that triangle ABC is congruent to triangle DEF, which implies corresponding parts of congruent triangles are equal. So AB will be same as DE, which is given to you, BC will be same as EF, AC will be same as DF, angle A will be equal to angle D, angle B will be equal to angle E, angle C will be equal to angle F. Fine? Because corresponding angles of two congruent triangles same. Okay? So name the pairs of equal angles. A will be equal to D, angle at B will be equal to angle at E and angle at C will be equal to angle at F. Let's look at the next question. We have again two triangles given to us and there are measurements of sides and angles given to you corresponding to the two triangles. You have to answer whether the two triangles are congruent or not. Let's talk about them. Roughly, if this is one triangle, this is another triangle. Say this is A, B, C, D, E, F. It's given that AC is 2.5, okay. BC is 5, angle at C is 75. Fine. Then it is given that DE is 2.5, DF is 5 and angle at D is 75. If you can carefully see, one side of triangle ABC is equal to one side of triangle DEF, another side of triangle ABC is equal to another side of triangle DEF. So two sides of one triangle are equal to two sides of the other triangle and included angle between the two sides in both the triangles are same. So by Sss Congruence Rule, both the triangles are congruent. So I can say AC is equal to DE, BC is equal to DF and angle at C is equal to angle at D. Therefore, by SAS congruence rule, which triangle is congruent to which triangle? C is corresponding to D. Perfectly, C is corresponding to D. So, B is corresponding to F and A is corresponding to E. So, I have triangle ABC is congruent to triangle EFD. Is it clear? So, yes, the two triangles are definitely congruent. Now, a triangle is given to you. ABC is an isosceles triangle in which AB is equal to AC. Side BA is produced to D such that AD is equal to AB. So, AD is equal to AB, and because ABC is isosceles, AB is equal to AC as well. Show that angle BCD, this angle, is a right angle. So, you actually have such a situation that you are producing this to such an extent and then joining it over here such that, what are you getting as a result? This angle should be a right angle. This is given equal to this and this is given equal to this. You know that angles opposite to equal sides are equal. If in triangle ABC, AB is equal to AC, this implies angle ABC, or I should say, yeah, ABC is equal to angle ACB, and the reason is angles opposite to equal sides are equal. Angles opposite to equal sides are equal. Fine. Moreover, because AD is equal to AC, AD is equal to AC, therefore this angle will be equal to this angle. Again, the same reason, angles opposite to equal sides are equal. So, angle ADC will be equal to angle ACD. Fine, same reason. Angles opposite to equal sides are equal. Now, if ADC is equal to ACD and ABC is equal to ACB, when I add this and this, so let me say this is 1 and this is 2, adding 1 and 2, what I get? Basically, left hand sides get added and you equate them to the addition of the right hand sides. You get angle ADC plus angle ABC is equal to angle ACD plus angle ACB. So, you have ACB plus ACD. This plus this is what? Complete angle C. So, this is equal to angle C. Let's take it as 3. By angle sum property of a triangle, you know that when I add the 3 angles of this large triangle DBC, I get the sum equal to 180. So, by angle sum property, angle D plus angle B plus angle C is 180. I am talking about in triangle DBC. This large triangle, in triangle DBC, if I apply my ASP angle sum property, angle at D plus angle at B plus angle at C is 180. Angle at D plus angle at B is this only. ADC is what? Angle at D. ABC is what? Angle at B. You are given by equation 3 that angle at D plus angle at B is angle C. So, this will be replaced by angle C. One angle C is already here. This is 180. Twice of angle C is 180. So, angle C is 90. Angle at C is 90 degrees. That is what you had to show. Angle BCD is a right angle. So, BCD angle, which is your complete angle C, is actually a right angle. Is it clear? Let's move to the next question we have. Line L is the bisector of an angle, angle A, and B is any point on L. So bisector of angle A means what? Bisector of angle A means what? That means angle QAB is equal to angle PAB. That is the meaning of bisector, right? So this is the bisector, so angle A will be divided into two halves, angle QAB and angle PAB, both of them will be equal to half of angle A. Then it says BP and BQ are perpendiculars drawn from B to the arms of angle A. So this is perpendicular, so angle AQB is 90 and angle APB is also 90. Fine, and this is equal to half of angle A, right? QAP actually, QAP is angle A. Also you can see AB is same as AB. Obviously if I talk about triangle BQA and BPA, one angle is this here and one angle is this here which are equal. One angle is this here 90, one angle is this here 90 which are equal, and this side AB is common, so obviously it is equal. So what can I say from these equalities? What can I say from these equalities? I can say that by AAS congruence rule, two angles same, one side same. By AAS congruence rule, I am having that the two triangles are congruent. So I can say that here I have AQB is congruent to triangle APB, right, by AAS congruence rule. The moment you have AQB congruent to APB, you have this first part proved. Now the moment I have these two triangles congruent, their very corresponding paths will be equal. So corresponding sides will be equal, corresponding angles will be equal, AQ will be equal to AP, AQ will be equal to AP, QB will be equal to PB, QB will be equal to PB, and AB will be equal to AB, that is obviously there. Out of this, what is fruitful to me? I want BP should be equal to BQ, that is B is equidistant from the arms of angle A. BP should be equal to BQ is what I need, which I am getting as a conclusion of corresponding paths of congruent triangles are same. So this implies I will just write what I need. BQ is equal to BP by CPCT, which means corresponding paths of congruent triangles. This is the second part, which is proved as a result of proving the first part that these two triangles are congruent, because these are nothing but corresponding paths of these two congruent triangles only. So we are done with the proof of both the paths. Clear? Next I have BE and CF are two equal altitudes of a triangle ABC. Using the RHS congruence rule, prove that triangle ABC is an isosceles triangle. Okay, so we have a triangle. Say this is A, this is B, this is C. What is given to you? Read carefully. It says BE and CF are equal altitudes. Equal means whatever is BE, same is CF. Fine. This angle is 90. This angle is 90. So I have angle BFC is same as angle CEB, which is 90. And if you focus upon triangle FBC and ECB, this side BC is common to both the triangles. So BC is obviously equal to BC. BC in both the triangles is sitting as the hypotenuse. Hypotenuse is same. Both the triangles are right angled triangles. Apart from that, one side is also same. FC is same as EB. So by RHS congruence rule, right angle, hypotenuse, side. This is right angle. BC equals BC. Hypotenuse of both the triangles is same. Both the triangles are right angled and one side of both the triangles is same. So by RHS congruence rule, I get what? B is going to correspond to B, C is going to correspond to C, and F is going to correspond to E. So I will have BFC is congruent to triangle CEB. Okay? Show that the triangle is isosceles. Now these two triangles are congruent, so their corresponding parts will be equal. I will have BF will be equal to CE, FC will be equal to EB, BC will be equal to CB. This is about the sides. 3 more equalities are going to come up as the corresponding angles are equal. So angle at B will be equal to angle at C. This angle will be equal to this angle. Angle at F will be equal to angle at E, which already we have. Angle at C will be equal to angle at B, which is again the same thing. So majorly I want angle at B equal angle at C because of corresponding parts of congruent triangles. The moment you have two angles same, sides opposite to two equal angles are also equal. So this implies AB is equal to AC, since sides opposite to equal angles are equal. And the moment I have complete AB is equal to AC, I have got two sides of this triangle are same, and therefore this triangle is isosceles. Okay? Hence proved. Next I have, in this figure, sides AB and AC of a triangle ABC are extended to points P and Q. Okay, so they have extended these two sides to points P and Q respectively. Also angle PBC is less than angle QCB. Angle PBC is this angle, angle QCB is this angle. It's given that angle PBC is less in magnitude, in measure, than angle QCB. I have to show AC is greater than AB. If I show this angle is greater than this angle, I know sides opposite to larger angle is greater. So if angle at B, the internal angle at B, internal angle at B is greater than internal angle at C, then side opposite to internal angle at B is AC. That will be greater than side opposite to internal angle at C, which is AB. So AC will be greater than AB. So my aim is to show that internal angle at B is greater than internal angle at C. External angle at B is given to be less than external angle at C. What is given to me is that only. So how I actually from here prove internal angle at B is greater than internal angle at C? Let's see. So this is what I have. If angle PBC is less than angle QCB, this implies minus of angle PBC is greater than minus of angle QCB. You know that if 2 is less than 3, minus 2 is greater than minus 3. When you multiply both sides by minus 1, you actually get the inequality reversed. The relationship between this exterior and this interior angle at B is that they add up to give you 180 because they are forming a linear pair of angles. Similarly, these two are forming a linear pair of angles. So what I do, if I add 180 both sides, because it's a positive number, inequality doesn't change. Now I know that angle PBC, which is external angle at B, plus angle ABC is 180. So angle ABC is nothing but 180 minus angle PBC. So 180 minus angle PBC is nothing but angle ABC. Similarly, angle QCB, what is it that I have? One more thing. Angle QCB is this angle QCB plus this angle is again 180, which is ACB. Again, they are forming linear pair of angles. So angle ACB is 180 minus angle QCB. So 180 minus angle QCB is ACB. And that is it. Angle at B, internal angle at B is greater than internal angle at C, and sides opposite to larger angle is larger and side opposite to smaller angle is smaller. So side opposite to angle ABC is AC and side opposite to angle ACB is AB. This is the proof of this claim. Is it clear? We have proved that AC will be greater than AB. Next I have shown that the angles of an equilateral triangle are 60 degrees each. Now this is really a cakewalk. How to show this? Equilateral triangle. You already know that the triangle given to you is an equilateral triangle. That means whatever is AB, same is BC, same is AC. These three sides have the same length. AB is equal to BC is equal to AC. If AB is equal to BC, then angles opposite to equal sides are equal. Opposite to AB is this angle, opposite to BC is this angle. So you will have, this implies angle A is equal to angle C, since angles opposite to equal sides, angles opposite to equal sides are equal. Moreover, if you take BC is equal to AC, you will have angle at A is equal to angle at B. You will have angle at A is equal to angle at B, because again angles opposite to equal sides are equal. So this relationship implies angle at A is equal to angle at B. So I have this also, I have this also. A is same as B, A is same as C. This implies angle A's measure is same as angle B's measure is same as angle C's measure. Now in any triangle, the sum of the three angles of the triangle is 180. So in this triangle as well, angle A plus angle B, angle A plus angle B plus angle C is 180. But angle B is same as angle A, angle C is same as angle A. So you get 3 times angle A is 180, that is angle A is 60. But angle A is same as angle B is same as angle C, so angle A's measure is 60, angle B's measure is 60, angle C's measure is 60. If the given triangle is an equilateral triangle, each angle is of 60 degrees each. In this right angled triangle ABC, right angled at C, it is saying that M is the midpoint of hypotenuse AB, that means AM is equal to BM. C is joined to M, and produced to a point D such that DM is equal to CM. Point D is joined to point B, show that triangle AMC, this triangle is congruent to triangle BMD. If I talk about triangle AMC and triangle BMD, you can clearly see DM is equal to MC and AM is equal to MB. Moreover, these two angles that you can see are vertically opposite angles which are equal, and therefore by SAS, two sides equal, one included angle equal, by SAS congruence rule these two triangles are congruent. Your first part is done. So I have DM is equal to MC, AM is equal to MB, and angle DMB is equal to angle AMC. Why? Because they are vertically opposite angles. And this was given to me in the question. Therefore, by SAS congruence rule, I have triangle DMB is congruent to which triangle? D is going to correspond to the vertex C M will be corresponding to vertex M and B will be corresponding to vertex A. So I have triangle DMB is congruent to triangle CMA. This is going to imply what? This is going to give you that the corresponding paths are equal. So I will have angle at D will be equal to angle at C. This angle will be equal to this angle. Moreover, I will have DB same as CA. So DB will be same as CA. These are the two things which are crucially something that we are getting out of these two triangles being congruent. Of course, we are going to get DM is equals to CM, MB is equals to MA, DB is equals to CA as three equalities related to the sides, corresponding sides of these two triangles. Angle at D is equal to angle at C, angle at M is equal to angle at M, which we have already written, angle at B is equal to angle at A. All these equalities are we going to get. But out of this, only two are important. One is angle at D is equal to angle at C. So I can write BDC. So let me write this angle BDC, try to write it fully, angle BDC is equal to angle ACD. And I also have BD is equal to AC. This is by CPC. Because BDC and ACD, these are, you can clearly see, if I talk about line DB and line AC, then DC line is acting as a transversal, thereby giving rise to this alternate interior angles which are being equal, and therefore, the moment one pair of alternate interior angles is equal, this transversal is not just cutting any two lines DB and AC, but it is actually cutting two parallel lines. That means AC and DB turn out to be parallel. So here, angle BDC is equal to angle ACD, which are actually alternate interior angles. So as this is equals to this implies DB is parallel to AC. The moment DB is parallel to AC, you can now consider the line DB, the line AC, and BC is the transversal. The moment I know that BC is the transversal intersecting two lines DB and AC which are parallel, then I know that the sum of consecutive interior angles is 180. So this implies angle DBC plus angle ACB is 180. Sum of consecutive interior angles. It is given to you in the question that triangle ABC is right angled at C. That means this angle C is 90 degrees. So you have angle ACB is 90 degrees. If angle ACB is 90, angle DBC will be equal to 180 minus 90, which is 90. This is what you had to show in the next part, that angle DBC is a right angle. So yes, angle DBC measures same as angle ACB, and therefore both are equal to 90 degrees. Second part done. I have to show triangle DBC is congruent to triangle ACB. See what approach now I am using. I have angle at B same as angle at C, which is 90 degrees each. DB is same as AC, we have already shown. And BC is equal to BC because BC is a common side to both these triangles. So by Sss Congruence Rule, both of them are congruent. Okay. So also, I have DB is same as AC. Angle at B is same as angle at C, which is 90 each. We just proved. One was given, one was proved. And I have BC is same as BC. This is the common side. Therefore, by Sss Congruence Rule, which triangle is congruent to which triangle? I have triangle. Now see, AC is same as DB. A is corresponding to D, C is corresponding to B, and B is corresponding to C. So triangle ABC is congruent to triangle DCB. right? I can say that. Or triangle ACB, if I say triangle ACB is congruent to triangle DBC, it's the same thing. The moment you know the correspondence between vertices, you can write the two triangles. After that, I have CM is half AB I have to show. The moment these two triangles are congruent, their corresponding paths are going to be equal. So I will have AB is same as CD. First of all, I will have AB is same as CD. Many more equalities will be there, but I don't need all that. The moment AB is equal to CD as a result of CPCT, I know that M is the midpoint of AB. But AB's length is same as CD's length, that means M is also a midpoint of CD. If M is a midpoint of CD, that means if M is a midpoint of CD, I can write what? I can write CD as CM plus MD. So I can write CD as CM plus MD, right? If AB is CM plus MD and CM is same as MD, isn't it? It is given to you, CM is same as MD, right? So I can replace MD by CM only because CM is same as MD and this is AB. So you get AB is twice CM or CM is half AB, and that completes the proof of all the four parts given in the question. Clear? Moving to the next, we have two sides AB and BC and median AM of one triangle are respectively equal to the sides and median of the other triangle. I have to show triangle ABM is congruent to triangle PQN. So ABM is congruent to triangle PQN. Now out of all these equalities, carefully observe, if I talk about triangle ABM and PQN, already AB is given to be equal to PQ, AM is given to be equal to PN. Now please see, BC is same as QR, okay, BC is same as QR, that is given to us, right? BC is same as QR, it's given, see BC is equal to QR. AB is equal to PQ and the median AM is equal to median PN. This complete side BC is given to be equal to complete side QR, but the fact that PN is a median means that N is the midpoint of QR. If AM is the median, that means M is the midpoint of BC. So I can say if BC is equals to QR, M is the midpoint of BC, so BC can be written as BM plus MC. I can write BC as BM plus MC and I can write QR as QN plus NR. But because M is the midpoint, BM is same as MC. BM is same as MC, so I can write BM in the place of MC. And because N is the midpoint as PN is the median, so PN is actually bisecting this side QR into two halves. So N is the midpoint, QN is same as NR. Since AM and PN are medians. Fine. This means 2 times BM is same as 2 times QN, or I can say BM is same as QN. So now I have BM is same as QN, AM is same as PN already given, and AB is same as PQ. So by Sss Congruence Rule, these two triangles are going to be congruent. So I say therefore AB is same as PQ. I already have BM is same as QN and I have the length of median same, AM is same as PN. Therefore, by Sss Congruence Rule, triangle ABM is congruent to which triangle? A is going to correspond to P, B is going to correspond to Q and M is going to correspond to N. these two triangles are congruent. So I have proved that triangle ABM is congruent to triangle PQN. Now prove that ABC, this larger triangle, is congruent to triangle PQR. The fact that these two smaller triangles are same implies that their corresponding angles are also going to be same. If these two triangles are congruent, their corresponding paths will be equal. Already I have these equalities between the three corresponding sides. So what matters to me is the correspondence between angles. So I will have angle at A is equal to angle at P. Angle at A will be equal to angle at P. That means I am talking about this angle. This angle will be same as this angle. Angle at B will be same as angle at Q, and angle at M will be same as angle at N. So I will have angle BAM. I will have angle BAM equal to angle QPN. I will have angle AMB equal to angle PNQ, and I will have angle at B is same as angle at Q. Majorly I need this by CPCT. The moment I have these two angles are same, let me rub this because I don't need this. Now it is very easy for me to prove the two bigger triangles are congruent, because in the bigger triangles I have AB is same as PQ given to me, BC is same as QR, that is also given to me, and angle at B is same as angle at Q I have shown. Therefore by SAS, two sides equal, one included angle equal, so by SAS congruence rule they are also congruent. So I have AB is same as PQ, AB is same as PQ, angle B is already same as angle Q, and I have BC same as QR. Therefore, by SAS congruence rule, I have triangle ABC is congruent to which triangle? A is corresponding to P, B is corresponding to Q, C is corresponding to R. So I have shown that even the bigger triangles are congruent. Fine. Moving to the next question, we have in this figure, what is happening is PR is greater than PQ. We all know that angles opposite to greater sides are larger in measure. So if PR is greater than PQ, PR is greater than PQ, that means angle opposite to PR is greater than angle opposite to PQ, right, which is this angle. So angle opposite to PR is angle PQR. This will be greater than angle opposite to side PQ, which is angle PRQ, because angle opposite to larger side is larger. Fine. Now please see, if PS is bisecting angle QPR, that means this angle is same as this angle. Angle QPS is same as angle RPS. Right? Because PS is the bisector. Now focus upon these two triangles, triangle QPS. In triangle QPS, I know by angle sum property, sum of the three angles is 180. So I have angle QPS plus angle PQS plus angle PSQ is 180. So I have angle 1, this angle and this angle, 180. In this triangle PRS, again sum of the three angles is 180. So you have angle PRS plus angle RPS plus angle PSR is 180. Both these sums are equal to 180, that means these two sums are equal to each other. So you have angle QPS plus angle PQS plus angle PSQ is equal to angle PRS plus angle PSR plus angle RPS. Fine? They both are equal. Now you have QPS is same as RPS. QPS is same as RPS. So obviously this cancels out. They both are same. So you actually get angle PRS plus angle PSR is same as angle PQS plus angle PSQ. I am given that PQR is greater than PRQ. PQR is greater than PRQ. Now PQS is same as PQR, right? So this is same as PQR. And PQR is given greater than PRQ. So this is greater than PRQ. Here you have angle PRS plus angle PSR, angle PRS plus angle PSR. Here angle PQR is greater than angle PRQ I have used, and the equality has changed into inequality greater than. Now see, this is PRS, PSR, PRQ, PSR. You can clearly see angle PSR, PSR same, this gets cancelled out. You have angle PRS is greater than angle PRQ. What is it that you had to show actually? Let's just confirm. You have PRS is greater than PRQ. Why? Because over here you had PQR is greater than PRQ. If PQR is greater than PRQ, then this equation's right hand side gets changed to PRQ plus PSQ. This is PSQ, not PSR. This is PSQ. And here it is PSR. So these two angles were not same. So what actually do you have is this equation. Let's just get back to it. Focus upon PRS and PRQ. See, PRS is this angle. PRQ is again this angle. So I can replace PRS by PRQ. Here you have angle PSR. Here already there is PRQ. And here it is PSQ. PRQ cancels out, right? PRQ cancels out. You're left with PSR is greater than PSQ, and that is what you had to show. Angle PSR is greater than angle PSQ. Is it clear? I hope all the 10 questions were very, very nicely understood. Please practice them very nicely. That's it from my side. Thank you.